Oh boy, have we got an action-packed episode for you today. Jade, what are you going to be talking about?
Well, it turns out the universe might actually be a little juicier than we initially thought.
All right. Sarah, what are you going to be talking about?
A major advancement in exoplanet searches.
Oh my goodness, and
I know.
Space Mike, what you going to be talking about?
Well, the moon race is officially on. Russia has laid out its plans on how they're going to get to the moon by 2040 with humans.
Nice. And then for our interview today, we have Dr. Dante Lauretta, the principal investigator for the OSIRISRex mission that just arrived at asteroid Bennu, and the chief science officer for Extronaut, which is a game that you're definitely going to want to hear about. So, this is tomorrow, Orbit 11.48.
Good morning. How's everything up in the sky?
And welcome back to the Observation Lounge at Station 204. As we often do at the beginning of our episodes, we hand it over to Space Mike for the launch minute. So, Mike, you take the launch minute. All of us, we're going to take a long break. Let's get some chocolate.
It has been a very busy week. So let's just jump right in because we have to talk about a Soyuz FG launch. This had a new crew on board with the Soyuz MS-11 spacecraft that had 3 cosmonauts and astronauts on board. It had Oleg Kononenko from Russia, David St. Jacques from Canada, and Anne McLean from the United States. And this launched on Monday, December 3rd at 11:31 Coordinated Universal Time from the Baikonur Cosmodrome in Kazakhstan. And just 6 hours later, after launch, the Soyuz MS-11 spacecraft docked to the POISC module of the International Space Station, which is a very fast rendezvous with the International Space Station. This was the first crewed launch on a Soyuz FG rocket after the failure of a Soyuz FD in October. They did have a return to flight with a Progress vehicle, an unmanned cargo ship on board, but this is truly a return to flight with crew on board of this variant of the Soyuz. Let's move right along because, as I said, it's been a busy week. We need to talk about a Falcon 9 Block 5 rocket that launched at 18:34 Coordinated Universal Time on Monday, December 3rd. And this was launching from Space Launch Complex 4 East at Vandenberg Air Force Base in California. And normally it's very foggy there. Look how clear it was on that particular day. Just awesome. This particular mission was the SSO-A/SERPA/SmallSat Express mission. It had a lot of names because it had 64 satellites on board from 18 different countries. And the booster, the first stage booster, landed on the drone ship called Just Read Instructions in the Pacific Ocean. This was the 3rd flight of this particular first stage booster. Its first flight was launching Vagabondu in May, and its second flight was launching the Mariputa satellite in August of this year. So very awesome to see that booster land for the 3rd time. And that was the first time that they've landed the same booster 3 times. Just amazing, just incredible. And all of the payloads were deployed successfully as well. But moving right along, we have an Ariane 5 rocket, the Rumble in the Jungle. And this launched at 20:37 Coordinated Universal Time on Tuesday, December 4th, from the Ariane launch area in the Kourou Space Center in French Guiana. Its payloads, it had 2 on board. The first was the GSAT-11 satellite, which is an Indian geostationary communications satellite and is India's heaviest satellite ever at 5,854 kilograms. The secondary payload on board was the GeoCompSat-2A, or the Geostationary Korea Multi-Purpose Satellite. It's a weather satellite being placed into a geosynchronous orbit for South Korea, and it's mainly going to be covering all of their different weather for that area, and it's not going to be like a polar orbiting satellite since it is specifically looking at the Korean peninsula there. But everything with this launch was successful, and they were able to launch this without any problems with it. But moving right along, we have a very interesting launch of another Falcon 9 Block 5 rocket, a super quick turnaround from SpaceX. And this particular rocket launched at 18:16 Coordinated Universal Time on Wednesday, December 5th from Launch Complex 40 at Cape Canaveral, Florida. Its payload was the CRS-16 Dragon cargo spacecraft, the 16th mission for the commercial resupply services, with over 2,700 kilograms of supplies and equipment, including the JEDI experiment, or the Global Ecosystem Dynamics Investigation. It's a LiDAR payload, as well as the Robotic Refueling 3 payload. However, the booster that was supposed to land at Landing Zone 1 at land didn't quite make it because of a failure of one of the hydraulics in one of the grid fins. And so it landed in the ocean, but it floated there, and that was successful. But in the trunk there, other than the JEDI experiment, you can also see the Robotic Refueling 3 payload, and there was also 40 mice for a rodent experiment. And interestingly, they had moldy food on board, which delayed the launch a day, but otherwise it was successful. Now, moving right along, we have a Long March 2D rocket, a two-stage Long March rocket from China that launched at 4:12 Coordinated Universal Time on Friday, December 7th, from Space Launch Site 2 in the Jiuquan Space Center in the Gobi Desert in Inner Mongolia, kind of northeast China, excuse me. Its payloads for this mission were the SaudiSat 5A and 5B satellites. They're Earth observation satellites for Saudi Arabia. And what we do know is that the satellites are headed into a low Earth orbit and will most likely be providing coverage over the Middle East. The two satellites, SaudiSat 5A and 5B, shared the launch with 10 microsatellites that are for pirate Chinese companies. Some of them were just technology demonstrators. Some of them had different types of cameras to have better optics on CubeSats to look at images of the ground. And everything else with this mission was successful. So that's really awesome. But probably the most exciting Chinese launch of the year is this next one, the Long March 3B rocket that launched at 1824 Coordinated Universal Time, also on Friday, December 7th. 2 launches in one day from China. And this launched at Launch Complex 2 at the Xichang Satellite Launch Center in Sichuan, China. And why is it the most exciting Chinese launch of the year? Because it was launching the Chang'e 4 mission, which is China's second lunar lander and rover headed to the moon. And it was built as a backup to the Chang'e 3, although this one has different science objectives. Chang'e is the name of the Chinese moon goddess, and Chang'e 4 is going to be measuring lunar surface temperatures over the duration of the mission, as well as measuring the chemical composition of lunar rocks and soils. It's also going to be studying cosmic rays and so much more. It's going to land at the South Pole Aiken Basin, and it's currently believed to be scheduled to land there around January 3rd, 2019, although we're not quite sure exactly, and maybe the Chinese aren't sure either. In any case, congratulations to everyone who had all of these successful launches this week.
Woo! Mike, take a breath while you can, all right? All right, breathe with me. So, Mike, what was definitely your favorite launch for this week? What was your pick for this week out of all these launches?
Well, honestly, I've been looking forward to the Chang'e 4 mission all year, but probably the most interesting to me was actually the CRS-16 mission having the failure of the booster. And even though one of the hydraulics lines for one of the grid fins failed, it was still able to land in the ocean, and they're in the process of recovering it right now. And I even saw a tweet from Elon Musk saying that unless there's a lot of damage, they might even be able to reuse this one. That would be incredible. So I'm not sure if I would even consider that a failed landing if the booster survived and they can still use it. Or I'm sure they can at least get something out of it, if not to collect data and see what the damage would be to salinity. But something I wondered about that I don't know, that maybe the community knows the answer to, is do you remember the missions that SpaceX did when they were figuring out how to do rocket landings and they had a couple of successful boosters that landed in the ocean? Did SpaceX recover those, or are those still floating around somewhere? I don't know the answer to that. So maybe you guys can jump in and help me figure out the answer to that, because it makes me wonder. I mean, payload fairings have washed up on different islands. It makes me wonder if there's a booster out there that someone's just going to find. I
got to say, boosters are pressurized, or they're basically pressure vessels with hot bits that go out the back. So I would imagine on landing, most of them probably just kind of ruptured weird, because that seemed to be what, if you go back and you look at the blooper reel that SpaceX released, a lot of those landings, basically the first stage just kind of zippers and explodes its guts everywhere. So I imagine that's probably what happened. So so maybe we can get Jeff Bezos to get his little sonar boat out there again and find some Falcon 9 first stages sitting at the floor. Of course, we got a lot of action in our chat room here. Andy Law on YouTube saying, "What an insane week for space news." Yeah, it definitely was. I got to say, landing zone Atlantic looks a little different than LZ1. Also, Peter Quinn on YouTube says, "The Jedi experiment. That sounds sidious." Nicely done there. And then in our IRC chat, Marty the Martian says, "Will the second mission be the return of the Jedi?" So who knows how that will go with that there. So fantastic.
Second mission is the molecule strike back and then Return of the Jedi.
The molecule strike back. Oh,
there it is.
Yep, there it is. Sarah, you've got competition this week for the puns, it would appear, with that.
Gauntlet is thrown. We'll see how I do.
Yes.
Wow.
All right. So, Jade.
Yeah.
Wait, really quickly.
What's up?
Do we have...
Oh, I'm sorry. Oh my gosh, I forgot to
dare
count.
you,
we have a
Jared.
bet on the line, Jared.
Don't mind me
Let's
here.
go real quickly what the launch statistics are. Yeah, so far this year, China is at 36 launch attempts with 35 successful. The United States is at 32 successful launches, although Zuma is kind of whatever. And Russia has 17 launches, 16 of which were successful. Europe has 8 launches, Japan 6, and India now 6 as well, for a total of 105 launches, 103 of which have been successful launching from Earth.
Yeah, and that Soyuz flight, if I remember correctly, was launch number 100 for the year. So fantastic
Yes, it
stuff.
was.
Yeah, we're in the triple digits. That's super exciting. And I can't wait to see what we end up with and then which year we can compare it to for how long it's been since we've had this many rockets fly.
First time we've had, I think this is the first time that we've had more than 100 launches since, I think, 1998. Hopefully the community can help correct me on that. But it's been a while since we've had more than 100 launches in one year.
Yeah, someone in the comments will definitely let us know. So, all right, very, very cool. Now, actually moving on, now that we freely can move on, Jade, you've got to tell us a little bit about what you titled Moist Mysteries from Space.
Yes. Indeed.
I
knew you'd appreciate that, Ben.
Obviously.
I'm going to put that in the show notes.
You are. No, you absolutely are. In case you didn't know, I'm just so smitten by the word moist. And any opportunity I get, which this is the perfect one. So, really quick background about the universe in 10 seconds or less. It's embarrassing how little we actually know about it. All those stars and galaxies and planets that we talk about, all of the stuff that we can see or that interacts with the electromagnetic spectrum in any capacity is only 5% of the stuff that's actually out there. This delicious looking pie chart, as you can see here, there's a large chunk, 26% dark matter, and that big old chunk of dark energy, and that little blue slice, that slice you eat when you're on a diet, that's the only stuff that we can actually see. Now, this story is actually it's a new finding, or it's a new proposal as to what dark energy and dark matter can actually be. And what this Dr. Jamie Farnes from the University of Oxford, he recently published his findings in the journal Astronomy and Astrophysics, and he proposes that dark matter and dark energy are not two entities, but are actually married into one, and we should call it a dark fluid. Ooh. And this dark fluid is pervasive throughout the universe. And really quick, dark matter is this substance that we believe is out there. It's very massive. And for instance, when we look at the rotational velocities of galaxies, we find that they rotate as fast in the outside as they do on the inside. Mm-hmm. And there's not enough mass there that we can see to account for that type of velocity. So they've proposed these things called dark matter halos, so it makes them spin real fast. Dark energy, on the other hand, is a lot more bonkers, because recently this Nobel Prize finding was that the universe, you'd think that if you throw something, it slows down. Well, the universe didn't get that memo. What it does is it actually accelerates the farther you look out. So the farther away the galaxy, the quicker it's running away from you, and that's dark energy. So if you marry these two into a very elegant solution called a dark fluid, basically what this then proposes is the existence of something called a negative mass particle. Now get this, a negative mass particle is something that if you exert any sort of energy on it, for instance, if I push Jared, he falls that way. Now a negative mass particle is the opposite. If I push Jared, it accelerates towards me. Whoa, and I'd be up for a surprise.
Yeah, that joke's on you, Jade.
Yeah, I know. And then I bump into Carrie-Anne. It would be a really cool
And then
chain
Carrie-Anne would
reaction.
bump into you, and it would be like a back and forth.
That would,
end
it
so
would
well.
be like that scene in what's that movie with Will Ferrell? The dun,
Yeah,
dun,
yeah,
dun,
yeah, yeah.
dun, 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 dun.
Night of the Roxbury.
Night of the Roxbury. Who would have known? They were actually doing a physics experiment in the club.
I'm good for something.
Yeah. And so moving on, this would actually explain pretty well some of the phenomena we see. So I had mentioned that galaxies with a consistent rotational velocity from the core to the perimeter, basically what this would help explain is that these negative mass particles would actually exert that negative, what is it even called? The non-pushy, the pushy backness onto the galaxies, and this would actually explain why galaxies don't tear themselves apart. Because at the velocity they're spinning, they should. That's like if I spin so fast my arms fall off. But galaxies' arms don't fall off. So this would actually kind of be a very elegant solution to that. And you're probably thinking like, this is kind of cool, but I mean, sounds like something like this might have been thought of before. You're absolutely correct. But it was thrown out because they thought, well, if this type of stuff exists, then as the universe expands, then these particles, they should dissipate and their effects should kind of disintegrate along with that. Well, what this theory actually proposes is something called a creation tensor. Basically, that means that these particles are constantly being created and refueling themselves, so to speak, so that the forces they exert on matter kind of don't dissipate. They stay consistently present and there.
Wow.
Yeah, and if you're wondering, well, how did he even think of this? This sounds bonkers. Well, he put this into a model that was tested using a simulation of the universe, and it was able to create a virtual cosmos whose galaxy distribution was formed as expected, and although there's no explanation for the nature of these negative mass particles or where they even came from, mass in general is kind of something not completely understood in physics, and this is a key thing to remember and a key thing to keep in mind. But Dr. Farnes does truly hope that this theory or this proposal is taken seriously, and further research will be done when the Square Kilometer Array, which is the biggest telescope ever built.
Yep, radio telescope.
Yeah, exactly.
So very cool.
Exactly. So upon its completion, he's hoping to do some more research that, if confirmed, this would be just paradigm shifting. And I love these types of stories because when you first hear about them, it's always a little far-fetched and it's always like, it's still very theoretical, but like, it's these types of things, like for instance, like gravitational waves, like, you know, back then, like, and one more thing, Einstein actually predicted something like a negative mass particle, and he proposed that in the general theory of relativity.
Whoa. So, because that's where we also got gravitational waves from.
Exactly, and you know what? So far, Einstein's like, his whole track record of predicting correct things is...
He's like 4 for 4 with a home run.
Yeah, exactly.
So,
He is kind of an Einstein.
So if we're going to put our money on it...
Well done, Sarah. And I love it too that Einstein said, gravitational waves are a thing, but we're never going to have instruments sensitive enough to actually detect them.
That's ridiculous.
By the way, they detected 4 more.
Exactly.
So it's becoming a normal thing now.
And it's getting an upgrade, isn't it? The supercomputer's getting an upgrade.
Yeah, they're doing that. So gravitational waves, everyday thing now. Who cares? Very cool story, Jade. And we really look forward to seeing if that hypothesis either way, it's a result. So
there you
that
go.
will be very, very interesting.
So in the chat room,
what's up?
Caleb Crow off of YouTube said, would the prevalence of negative mass particles bring us closer to stabilizing wormholes if we could create them?
That is a fantastic...
Holy smokes, that is beyond my understanding of
Well,
physics.
because when you think about a wormhole and how if they did exist, then they'd be relatively unstable, no? Since...
Yeah, I legitimately don't know.
So
I'm
I'm concerned that
Anyone else? Anyone else know?
But the nature of it is a fixed amount of matter it's so dense that it has sort of punched a hole in the fabric of space-time, right? Yeah. So that matter isn't going anywhere. So why would it be unstable?
I would just think that the environment you need to create a wormhole theoretically would be so volatile and so kind of. I mean, when I think of wormholes, I think of like supernovae explosions. I think of like black hole merge or something, intense, dramatic things. And so I think just because of the nature of its birth, the nature of its existence would probably be a little volatile, I'm thinking.
I don't know. But is it a merger that creates it, or is it the mass, right? Is it the hyper-dense singularity?
Oh, I don't know.
Right?
I have no idea.
That would be, questions for future hypotheses and maths.
Yeah, you got to figure that out. So,
Yeah.
and I kind of actually want to ask Dr. Lauretta here.
Yes, please.
I don't know if something like this is in your wheelhouse. I'm just kind of pitching it to you here real quick. But the square kilometer array is a radio interferometer. Combining them all together to make one larger radio telescope. Is there some way that you could do that with a spacecraft? Like, if OSIRIS-REx is done with its mission by this time, could you actually use the comms package on board in order to do that, or do you have to have like a dedicated mission to do something like that?
Great question, and you can definitely build interferometers in space. That's where the future of exoplanet surveys are going in order to get the precision that we need. I don't think you could do it with the OSIRIS-REx spacecraft after we've dropped off our sample back to the Earth, because it does require extremely tight knowledge between the locations of the different spacecraft. And we're not equipped for that. You need usually some kind of laser comm so that you're getting, ultra precise sub-millimeter resolution in terms of where the spacecraft are relative to one another. And that was definitely not on the requirements list when we put the spacecraft together.
Yeah, so I was just thinking of LISA Pathfinder with that there, and the eventual LISA mission that European Space Agency is aiming to do a laser interferometer in space. So yeah, that's cool. I completely forgot about the fact that you have to have ultra precise positioning of your spacecraft in order to pull that off. So in other words, don't hire me to engineer that mission for you. Moving on real quick. Speaking of engineering missions, Mike, we're going to be talking about Russia to the moon. But if you thought the United States was really throwing the football down the way, they've sort of got a little bit more extensive of a timeline than what we've got for that.
Yeah, I mean, they basically, with the way that political situations are going down right now, I'm not going to go into why they're putting forward this plan, but they've put forward a 3-phase program to get to the moon and send humans to the moon and build a lunar base, or at least have humans on the moon by 2040. And check out this video that we have from Roscosmos that goes through a bit of the stuff that they're planning on. First off, they have kind of similar to what NASA announced recently. They're going to be sending small lunar landers that are just having science experiments and payloads on board. And eventually they're going to do stuff that goes into sample returns. And with all of this, there's a lot of different stuff that they're planning on doing. First, a lot of their technologies that they want to test for, they're going to be doing at the International Space Station first with their Nauka module and Node module. And here's an example of their sample return missions. But the biggest thing is that they need to develop their Federazia spacecraft, which is their next crewed spacecraft that is going to be sending crews not just to the International Space Station, but potentially to the moon. And they have a couple of different plans on how to do that. They might even be able to land the capsule on the surface of the moon, similar to the way that the Dragon capsule had their Super Draco thrusters that would allow it to land on the surface somewhere. They also have different lunar modules, similar to the Apollo program, that they are starting to design, and that would go down to the lunar surface and then come back up and rendezvous with the Federazia spacecraft. And they're quite far along in the design of the Federazia. I mean, just from this view of the inside, that looks much more comfortable for 4 people than it currently is for 3 people inside of their Soyuz spacecraft. And of course, they're having digital systems that are right there up close and center to the astronauts that are actually going to be piloting the thing. So they no longer have to use the stick that they currently use on the Soyuz spacecraft.
Yeah, the finger longer thing, whatever it's called. I can't remember the name of it. So.
Yeah. I'm sure it has an official title. But the whole thing with this, though, and here's a graphic example of how they might land the Federatia spacecraft by itself on the lunar surface. I'm not sure what missions would call for that, but all of this is kind of going about the Deep Space Gateway. They're upset with how things are going, so this is kind of their initial idea for their own gateway. And it wouldn't be put in a Lagrange point or in a really high elliptical orbit. It would be in a low lunar orbit so that it would be highly accessible to the lunar surface, so that they could start putting modules like you saw there in that animation of having their own lunar base. And right now, all of these plans that they've put forward is to have one of their cosmonauts on the surface of the moon by 2040 is under their own budget by themselves. Now, of course, they've been trying to reach out to China and the United States and everyone that they possibly can to try to go together towards the moon. But this particular plan and that 2040 date is if they receive no additional help or collaboration from anyone else. However, with all of their different partnerships with China, that timetable might be advanced up because China has very similar plans. They're not planning on building any sort of space station in orbit around the moon, but they are planning on going to the surface of the moon and building their own lunar base as well. So that might be a joint Sino-Russian project. We'll have to see for it. But I just think that this is really cool that these plans are being put forward and that even though the Russian space industry is struggling, they've put forward these ambitious goals and are just like, whether we get help or not, this is what we're willing to provide for funding and what we hope to do by this date. So I just think that that's really cool.
Yeah, and of course, it always comes down to no Buck Rogers with things like that. So funding is always a difficult thing, but that doesn't mean that international partners can't bring funding to the table in order to help with missions like that. And international partnerships are really important to missions of all kinds. Like Dr. Lauretta, you guys have a couple instruments on board of OSIRIS-REx that are international partners, right?
Yeah, OSIRIS-REx is a great international partnership. The premier international instrument is the laser altimeter from the Canadian Space Agency. And they actually just fired and got their first data on Monday. So it's been really exciting. They've been in town here in Tucson, Arizona to see their data coming down. We work a lot with the Japanese Space Agency. They don't have an instrument, but they have their own spacecraft at an asteroid right now, the Hayabusa 2 probe. And I'm a member of that science team. And we've brought our Japanese colleagues over to become part of the OSIRIS-REx Science team. So we're really looking at these as joint asteroid explorers, sharing knowledge and information, helping each other out. We like to say we're all pioneers on the asteroid frontier, and if we don't work together, then none of us will survive. We have a lot of support on the science team internationally, the French Space Agency, the United Kingdom, the Czech Republic. We have co-investigators from Spain and many other places around the world. So it's a really great, especially now that the scientists are all gathering together and really starting to process the data from the asteroid. I can honestly say it's been one of the best weeks of my life, and it's because of the people that have come here to help with the data processing.
Yeah, so it's always advantageous to have those partners from all over the world come together, especially if you could collaborate on separate missions that you have, like you were talking about with Hayabusa 2. And I really like this from Peter Quinn from our YouTube chat room, which says, we must remember that the moon is like Antarctica. No one country, person, or business can own the moon. Although I'm sure people would challenge that notion quite a bit. I still feel like that's initially how things are going to end up working with that there. So very, very nicely said, Peter. Now, moving on to an interesting study, Sarah, involving one of my favorite observatories here on the Earth. ALMA is one of my favorite observatories, and a lot of people don't know that. So
I did not know that it was one of your favorites.
Now you know.
I do. It is a pretty amazing instrument. So ALMA is the Atacama Large Millimeter Submillimeter Array in the Atacama Desert in Chile. And it's a high altitude instrument, so it has less atmosphere to look through. Atacama is one of the driest places on Earth, so it doesn't have a whole lot of moisture in the air. It gets amazing data, so I definitely understand why you love that instrument. And move it. They have the ability to move all of their antennas. It's
so
amazing.
Again, they can change the size of the interferometer, which means you could change the size. You could change the angular resolution, which means you could get better imagery. Which is, be still my heart.
And actually, this study has triggered probably a move to expand those antennas to get better data for this. Okay, so a study from the University of Astronomy and Astrophysics at Peking University, they were looking at the star-forming region in Taurus. And it's been done before. They were looking for protoplanetary disks, and also been done before. And the difference between other missions and this one, other studies, is that other studies have been biased in the past. They were looking for the brightest protoplanetary disks, or potentially protoplanetary disks around protostars. And so we were looking for the brightest ones before, because that would give us the best chance of finding really supermassive planets if they're in there. If there are rings, little detectable rings in those protoplanetary disks, we look closely at those, we might be able to find Jupiter-sized planets, even super Jupiters. But now we're able to look for super Earths and Neptune-sized planets. And that's what this study was designed to do. It didn't bias the protoplanetary disks that it looked at. It didn't look for the brightest disks. It just picked 32 disks. And within those 32 disks, 12 had rings that might indicate super Earths or mini Neptunes. And that is just so amazing to me, because we're no longer in a place where we're thinking, okay, there are some planets out there, we probably aren't going to see them as they're forming. We're going to be able to actually find forming Earth-sized planets using instruments like the ALMA. And I think that's just absolutely mind-blowing. I think astrophysics is changing as we speak.
Yeah, and I was going to say, your data is only as good as your instrument coming with it, and ALMA is one of those instruments that just, it seems like every time you get a new data release from it, it's just getting better and better and better.
Absolutely.
And a lot of that has to do with processing the data here on the ground as well.
Yeah.
And we're starting to get really good at that with that. So, man, there's just a ton of exoplanet telescopes and instruments on big telescopes that are coming online. So, which is just ridiculous. I can't even. I'm so excited about all this data.
And we haven't even gotten to the James Webb yet.
Yeah, and also future missions as well.
Yeah.
The one we talked about a couple weeks ago, CHEOPS, with that one. Also using data from TESS as well to look at other things. So holy smokes.
Yeah.
So this is going to be great stuff. So super looking forward to that. So what we're going to do, we are going to be talking to our guest, Dr. Dante Lauretta, when we come back from a break in just a few seconds here. But before we head to that break, I would like to thank our Escape Velocity citizens. These folks giving us $10 or more per episode on our Patreon, and they do, it's just, I think it's just amazing that you folks are basically saying that you're willing to contribute to this show, which basically is our platform to evangelize the universe to people around the world. We tell people about what's happening in space. We tell people about things like we're looking for gaps in protoplanetary disks that tell us planets are forming, that Russia's getting ready to do a base on the moon, whether anybody's going to do it with them or not. The universe is moist. Things like that. It's just, we can't do that kind of stuff without your contributions. So thank you so much. And if you would like to help support the show, you can head on over to patreon.com/TMRO and take a look at what you can do for that. And just a reminder too, because we often say this towards the end of the show, I want to say it at the beginning of the show, which is that financial contributions aren't the only thing you can do to actually help out tomorrow. We need things like help with code and other stuff like that, to build chat rooms or to work with interactivity and other ways like that. So you can go over on to community.tmro.tv and actually we do have a little post in our community forum there about ways that you can help out. And we're just looking for a multitude of ways for people to help us out. So if you'd like to help us out, you don't have to necessarily go to our Patreon and do that. You can come straight to us and tell us how you want to help us out. And that's extremely important to us and to making a better show for you and the whole community that watches us. So we're going to take a quick little break, and when we come back, there will be more tomorrow right after this.
3, 2, 1. And liftoff of OSIRIS-Rex.
And we have indication of spacecraft separation.
Well, you'll all be real glad to know we got everything just exactly perfect.
This represents the hopes and dreams, hard work, blood, sweat, and tears of thousands and thousands of people.
That was me 2 years ago when we launched the OSIRISRex spacecraft and sent it off on its journey to asteroid Bennu and back. OSIRISRex has traveled through deep space and is now approaching its target destination. We've already got our first images back from this amazing asteroid, and the scientific data is being downlinked to Earth. I've taken that experience and put it into our new board game, Downlink. In Downlink, players lead a space agency to develop missions of planetary exploration, choose to launch rockets, deliver spacecraft to targets around the solar system, complete real space science-based experiments, and downlink that science data back to Earth for analysis. The game comes with a game board that maps out targets in the solar system. There are rocket systems you can launch from authentic launch sites around the world. There are 9 different types of spacecraft in the game to explore the solar system with, and 15 different science instruments to make your scientific discoveries. Players can choose from many target destinations across the solar system. Once at these locations, the real fun begins with scientific discoveries. Players also manage their ground stations, critical elements for getting data back to Earth for analysis. With Downlink, have fun by being a space mission leader.
And AOS back here at the lounge at Station 204.
Isn't that awesome?
Yeah, that is pretty awesome, I gotta say. And speaking of awesome, that awesomeness happened because of the awesome Dr. Dante Lauretta, who we've got on the show today, principal investigator for OSIRISRex. Yep, the head cheese on that mission. And as we just saw, the chief science officer for Extronaut as well, which we'll be talking about in just a little bit. So, Dr. Lauretta, welcome to the show.
Thank you. It's great to be here.
All right. So just to talk a little bit, because earlier in the show you were talking about this has been one of the most exciting weeks of your life. So why? Why has it been so exciting for you? For our viewers who may not know why.
So on December 3rd of 2018, we arrived at asteroid Bennu. And the first thing I did, I woke up and I said, this is a day I put on my calendar 10 years ago. Literally, I've been thinking about this week for the past decade as we convinced NASA to fund the mission, designed the spacecraft, built it, tested it, launched it, sent it on that over 2-year journey through the solar system. This week, the data started coming down in spades, and the science team descended upon Tucson. We have this big bullpen area where everybody is looking at the images. We're looking at the geology, the spectroscopy, understanding the geophysics of what's going on the asteroid. And it's a dream come true. I mean, it's a scientist's Christmas and birthday and anniversary all rolled into one. Everything is happening. It's all going really well. Everything is working the way it's supposed to work. And we have definitely picked the right asteroid. And this team is super excited to go on the journey of exploration that we get for the next year of Bennu.
Now, I'm sort of noticing sort of a theme, because we've had a couple principal investigators on tomorrow during Orbit 11. Like we had earlier this year, we had Alan Stern from the New Horizons mission, and then we also had Bruce Bennert from the InSight mission as well. And all of them talk about the fact that these missions start way before even the design work begins on these spacecraft. So how do you do that? Like, what's the process of basically like going to NASA and saying, hey, can we go grab a piece of an asteroid and bring it back? You're like, hey, you want it? You want some? So.
It kind of starts there. I mean, it really is. There's an amazing program at NASA that's called the Discovery Program. And then there's a similar one, the one that we're in called the New Frontiers Program. And these are principal investigator-led missions. The Discovery Program started in the mid-1990s, and the first 2 missions were the Near-Earth Asteroid Rendezvous and Mars Pathfinder. And I know it was part of the Faster, Better, Cheaper, if you remember that era, which got a lot of slack for causing issues, but it really did launch this idea that the community could come forward to NASA with the ideas for planetary exploration missions. And now that is the norm. Discovery is wide open. If you have an idea for a mission of solar system exploration, you can submit a proposal to NASA's next announcement of opportunity. They try to get those out every 2 years. Sometimes they do that, sometimes not, but we've had a good record lately. New Frontiers, when they recognized how valuable the Discovery program was to have these community-led efforts, they made a bigger version of it. It's about twice the budget of a Discovery program. And it's a little more constrained in that they say, well, we're going to put $1 billion down on each New Frontiers mission. So there's a two-step process. First, it goes to the National Research Council and the Space Studies Board to produce a document called the Planetary Science Decadal Survey. And in that document, the community gets to tell NASA, focus New Frontiers on these following mission concepts. It's usually on the order of 8 different ideas that are in there. And then teams gather around those and then go forward. Usually a university, a government center, like we're partnered with the Goddard Space Flight Center in Maryland, and an industry partner, Lockheed Martin Space, is the company that built our spacecraft and is now doing spacecraft operations for us.
So, how do you have to compete? You have to compete for this, right?
Yeah, I compare it to the NCAA basketball tournament, right? So literally you'll have 24 or more teams go in for each one of these flight opportunities. So it is a risk career-wise because the odds of actually winning this are not that great. But you go in and then you get to the championship game. NASA gets all those proposals. They convene their what we call the TIMCO board, Technical Management Cost Review, and then they select 2 or 3 or sometimes 4 to go into what we call phase A, the concept study phase, where you get some money from NASA to build a concept study report. And then from that, there's the championship that's crowned. One team is selected to fly.
So what's it like for you? Because, I mean, you put a lot of, this is like life's work that you're putting in here. I mean, this is going back 10 years, I don't know a lot of people who necessarily stay at the same job for longer than 10 years, but you're not just doing the same job, you're like on the same vehicle for 10 years. What's that like from your perspective? Like, how does that feel to you?
Well, you can't think in terms of the total length of the mission. I actually got started on this adventure in 2004, and we did submit the asteroid sample return concept to the Discovery program twice. The first time we got rejected out of hand, and rightly so. We were pretty naive and just getting our footing. The second time we made it to that championship game, but we lost to a mission called GRAIL, which was a lunar gravity field mapper. And so the third time we went in was 2008 when we started working on the New Frontiers proposal. And you got to take it one piece at a time. The good news is the job really changes over the course of mission development. You start out with a very small focused group working on the proposal, and then the team builds and builds and builds. You go from PowerPoint to real hardware to having a spacecraft that you're watching come to life, going through the environmental qualification testing. The launch campaign, I would say before this week, the launch campaign was absolutely the best part of the job so far. And now getting to the asteroid and getting back into the science frame of mind and beginning this journey of exploration. As I say, if you're going to go on a journey this long, you've got to enjoy the ride.
Yes, and that's a good sentiment, I think, just to have in life in general. But I'm curious, so you mentioned, right now there's this big push for, we just completed the reconnaissance of the solar system. So, really getting into, studying the different bodies. So, I mean, I've heard a lot of cases for planetary exploration, a lot of cases for going back to the moon, but why asteroids? I mean, what, in so many words, like, why go to an asteroid? And how did you convince NASA that, hey, we should go to an asteroid?
So we heard earlier about the ALMA mission and probing the protoplanetary disks and understanding the earliest stages of planetary formation. Well, asteroids are the geologic remnants of our solar system from that era. So when you think about geologists, right, they put together the timeline of Earth history, and they start out with the rocks that are forming today or the sediments that are forming today, and then you go back in time down to those deeper and deeper layers, and you're understanding the evolution of the Earth. Well, if you want to understand what happened before the Earth formed and how planets formed, and particular interest of mine is how life originated, you got to go back and understand the building blocks of those planets. They're not preserved on the Earth. The Earth has been very geologically active for 4.5 billion years. They're not preserved on the moon, although the moon does preserve an earlier era of solar system history from the dawn of the formation of the Earth-Moon system. But the meteorites and the asteroids, which meteorites are samples of, those are the oldest rocks in the solar system. Literally, the very first solid material that formed, that went on to grow into planets, is recorded and preserved in these samples. So from a scientific perspective, you want to understand the planetary formation process. These are the samples you want in your laboratory. But the tagline for OSIRIS-REx is exploring our past and securing our future. And asteroids, I think, play a large role in the future of space exploration as well. I've gotten very excited about the emergence of asteroid mining as a legitimate business enterprise. When I wrote the name OSIRIS-REx down, I put in there the acronym resource identification. And I thought, I'm just going to let my sci-fi geek flag fly. But now that we're there, we have companies that are contacting us, wanting to understand what the implications of our technology and our data are for asteroid mining. And I think the best commodity is the water. Jade, and I know you like moist things. Well, I think a lot of these asteroids are moist, and we're going to be able to extract that water and use it as rocket fuel to further destinations in the solar system. And then finally, we worry about asteroids impacting the Earth. Our target asteroid, Bennu, is one of the most potentially hazardous asteroids. The good news is, if there's going to be an impact of Bennu and the Earth, it's going to happen in about the 2150 to 2180 timeline. But I look at what we're doing as the gift to the future. If the people of that era on Earth need to come up with an impact deflection mission, they're going to want to know everything we learned about this asteroid or similar asteroids in order to make that happen.
Wow. I mean, now my question is, how come we didn't go sooner? That's
Mine too, trust me.
Compelling. My gosh, thank you so much.
So we've got a question from our chat room here from Space Vogel, which is asking, what were the biggest challenges with the OSIRIS-REx mission?
Definitely the biggest challenge is getting the sample off the asteroid surface. And as we designed the mission and we started to simulate spacecraft operations, we were working with teams that had done the Phoenix Mars lander. We had also worked with teams that had done Mars Reconnaissance Orbiter, MAVEN, and Juno. Those were our spacecraft heritage line. And then from the Goddard Space Flight Center, we had a lot of Earth orbiting expertise. We realized that trying to fly a spacecraft in a microgravity environment like around the asteroid is a real challenge, because unlike moving around a planet with a very large gravity well, the small forces like solar radiation pressure or spacecraft outgassing or even thermal radiation emitting off the asteroid surface actually push the spacecraft around quite a bit. And we're trying to pinpoint target a specific location on the asteroid surface. So the flight dynamics and navigation are still the biggest challenge. And in fact, we're still in what we call the navigation campaign. We just sensed the asteroid's gravity field this week. We got a measurement of the asteroid's mass. We're designing an orbit insertion for New Year's Eve of this year. And the navigation team, they run the spacecraft for the next 2 months. I've told the science team, actually, you guys need to back off. Let the navigation team learn how to fly this thing. And then the science campaign really kicks off in late February and the spring of next year.
There you
Awesome.
go.
Interesting.
Oh, so I've actually got the same question as Launchpad Astronomy on YouTube. OSIRIS-REx is primarily a sample return mission, but what kind of science are you going to be doing in situ?
Yeah, the great news is we are going to do an unprecedented job in mapping a planetary body, driven by the sample science requirements. We've got to find a site on the asteroid surface that is safe, that we can get material from, and has high scientific value. In order to do that, we are going to get global mapping resolution at 5 centimeters per pixel of the entire asteroid. We're going to do that in 4 different color filters. We are going to have this awesome Canadian LiDAR mapping down to centimeter scale roughness resolution. And we're the first planetary mission to fly both a visible and near infrared spectrometer and a thermal emission spectrometer. So we have almost near complete coverage from 0.4 microns out to 100 micron wavelength to understand the spectral properties and therefore the mineralogy, the thermal properties, and the chemistry of the asteroid's surface. When we get down to characterizing the site on the surface where we think we're going to get the sample from, we'll be getting images at 3 millimeters per pixel resolution. We will have never had data from an asteroid surface of this fidelity and this comprehensive. We are taking our time. We are going to spend all of 2019 mapping this asteroid, analyzing the surface. We don't expect to go get that sample until July of 2020.
Wow. That actually brings up a good question that Johnny Spacer had in our chat room that says, Bennu looks like a loose pile of rocks. What does our guest think about Bennu's composition?
Well, when we chose Bennu, from a science value perspective, we really wanted something we thought was the source of the carbonaceous chondrite meteorites. And for those of you who aren't familiar with meteorite nomenclature, these are the most primitive meteorites in our collection, i.e. the oldest materials in our solar system. And they're really rich in water, especially in the form of hydrated clay minerals. And most importantly for our investigation, organic material, especially important compounds like amino acids and nucleic acids, which we think were the seeds of life that these kinds of objects delivered to the surface of the early Earth about 4 billion years ago. I think the viewer is right. We are looking at a rubble pile structure here. One of the things that we determined from the ground, we used both the Arecibo and the Goldstone planetary radio telescopes to characterize the shape of the asteroid in 1999 and 2005. And we predicted this kind of spinning top shape. And that is really strange. It's got this bulge around the equator. And we thought right away, that must mean this thing is a rubble pile, that the spin of the asteroid is driving material to migrate down to the surface and build up that equatorial ridge. And we are seeing that we got that right answer with the Arecibo data and now what we're seeing in the spacecraft imagery.
Interesting. Really interesting. This is a great conversation, and I know there's more like comments in the chat room. But one thing that keeps coming up is all the posters that you have in the background.
Yes.
Would you mind really quickly just kind of going over what you're standing in front of?
Sure. Well, I'm really a big fan of merging the arts and the sciences. In fact, just on Saturday, December 1st, I put on a variety show at our local Fox Theater where awesome. I had science, humanities, comedy, music, acrobatics, and we really want to celebrate scientific inquiry as a manifestation of the human spirit. So I really wanted us to have art and graphics that capture the different stages of the mission. And the 3 posters that I have behind me are commemorating the launch in 2016, the major event of 2017, the Earth Gravity Assist, and of course, Bennu arrival, which occurred on December 3rd, on Monday of this week.
That's awesome. That's really, really awesome.
Yeah, go ahead, Mike.
I do have a question, kind of going back to the shape for a moment. The only asteroid that I knew of before a lot of recent discoveries that was kind of shaped like a diamond or a spinning top, as you said, was Steins, asteroid Steins or Steens in the main asteroid belt. So seeing up close pictures of Bennu and even the images that we've been getting from Ryugu and a lot of these different asteroids that we've been trying to rendezvous with all kind of have this similar shape. And you say that you predicted that. Is this, with that shape, is that just the type of shape that a pile of rubble would collect into? Or does this have something to do a little bit more about how their mass and gravity? Like, why do we keep seeing asteroids that have that diamond or spinning top shape?
It sounds like you were here with the science team all week long, because we've been asking ourselves that question continuously, and different ideas are cropping up. We did discover these shapes using the radar data, and we see that a subset of the near-Earth asteroid population has this, but not all of them. We also had seen asteroid Itokawa. That was the target of the first JAXA Hayabusa mission. That doesn't look anything like this. That looks like a peanut or an otter, they like to call it. That's what we call a contact binary. It really looks like 2 large chunks of asteroid kind of contacted each other, and they're rotating around a common center of mass. So in order to get that spinning top shape, we had a couple different ideas. One, there's a phenomena that we've learned about over the past 15 years or so called the Yorp effect. And what this is, it's kind of like solar radiation pressure and thermal emission acting on the asteroid like a windmill. And you can have the Yorp effect start to increase the rotation rate of the asteroid and spin it up, adding angular momentum to the surface, and then driving material to migrate down and build up that kind of equatorial ridge. So that's one idea that we've thought about for forming it. Another one is related to the fact that a lot of asteroids are binary systems. You have a primary and a secondary or a satellite, and that system may decay down, and the ridge may be the collapse or the accretion of that secondary back onto the surface of the primary. And now we've been kicking around ideas that maybe this is something fundamental to the formation of the asteroid. In particular, Bennu is too small to have existed as a solitary object over 4.5 billion years. A related phenomenon to Yorp is called the Yarkovsky effect. Instead of spinning the asteroid, the Yarkovsky effect changes its orbit, particularly its semi-major axis, and will shrink it and make it become a near-Earth asteroid. But the Bennu probably originated in a catastrophic disruption of a much larger object in the main asteroid belt, something on the order of 100 kilometers in diameter. And maybe the reaccretion of the rubble from that event had some angular momentum associated with it, and so it kind of spun down, and in a similar manner to why you get a protoplanetary disk forming around protostars, maybe you get these equatorial bulges as these objects reaccrete after a catastrophic disruption. The good news is we're going to be able to test all those hypotheses, not just with the data that we get back from the spacecraft, but we are a sample return mission. Each one of those has different implications for the nature of the sample. So when we get it back into our laboratory, we already have the team connecting hypotheses to analyses of the return material so that we can better understand what's going on here. But it's brand new. I mean, it really is the forefront of asteroid exploration, and we don't know the answer as to why these things have the spinning top shape yet.
Interesting.
Just to clarify, that effect, is that the York effect, the Yorp effect? I'm not sure I heard you correctly.
Y-O-R-P.
Cool.
Yorp, yeah. Interesting name for that. So I wanted to talk.
It's actually an acronym. That's the 4 scientists whose theories came up with that
Aww.
idea.
Excellent.
Of course.
We should make one of those.
Yeah, we should. So I want to talk to you a little bit about Extronaut, which is a project that you worked on leading up to the launch of OSIRIS-Rex. So just go ahead and tell us, what is Extronaut?
So when I first got involved in the OSIRIS-Rex project, I was interested in the science, and I was a meteorite scientist. I knew we needed pristine material from the dawn of the solar system. But I also take my educator's role really seriously, and I was particularly excited about the education and public outreach component of the mission. And then really one of the only catastrophes that happened during development was the EPO program was canceled, and I was devastated, and I was pissed off, quite honestly. I wasn't happy about it. And so I realized, and I appreciate that, I think one of the main reasons that we fund these kinds of expeditions as a nation and as humanity is to inspire the next generation and to educate people and to make them think big thoughts and go after big projects. And I couldn't let the education program just die. So I decided to try to do it privately. And we tried a lot of different things. We had educational curricula and workbooks and experiments, and it was hard to get into the educational system because they're overwhelmed and underfunded, and they got a lot of things that teachers need to take care of. I started working with an after-school organization called the Boys and Girls Clubs, which I actually went to as a kid, and it's really important to me, and doing after-school science clubs. And I came to realize that there was this misconception. It was great to see all those rockets launching at the beginning of the segment today. Because most kids and a lot of adults think that the rocket is the vehicle that goes to the planet, and I call it the Bugs Bunny model of planetary exploration, where Bugs gets in the rocket and it flies through the solar system, and the whole thing lands on Mars. And so I started a flashcard series where I had the first stages and the second stages and the spacecraft and the fairings and the side boosters, solid boosters. And I had Deltas and I had Atlas rockets, just to explain the different kinds of rockets that are out there. And the kids started to make it a game, like a trading card game, and trying to build the rockets on the table. And I was like, well, I really love board games. It's one of my favorite hobbies. I play with my kids all the time. And I've always wanted to design a board game. So let's see if I can come up with a game that will teach kids about how rockets work. And the Extronaut, the game of solar system exploration, was born. I put it on Kickstarter, and it did well, and it got funded. We were able to print it. It's gotten some awards and accolades. We've actually sold about 10,000 copies so far. And so we've kind of continued to develop space-themed games around that idea. Our second game was called Constellations, the game of stargazing in the night sky, and it's all about the patterns of stars and the different kinds of stars and stellar evolution. And now we have Downlink, which is kind of taking it to a new level. I'm really interested in the strategic board games where you've got to, think about where you're applying resources, and you've got big decisions that will definitely influence how the game plays out. And so Downlink is all about not only the rockets, but the spacecraft, the science instruments, the discoveries that you make. And it's international in flair. In fact, all of the rockets that we saw launch are in the game. Most of those launch pads are in the game. We also have the JAXA Tanegashima Space Center, which I don't think we saw a launch from this week in there. So it kind of celebrates the international nature of planetary exploration, and you get to learn something along the way.
That's awesome. Actually, Dariachi in our chat room says, is there any plan to put out updates for any of these games as the rockets and missions change? Which it sounds like you did kind of answer that. Are there other updates that might be coming that we don't know about quite yet?
Well, I don't think I'm going to stop designing board games. You kind of get the bug, and it's actually a lot of fun. There's a lot of analogies to designing a space mission in terms of what you think you're doing at the beginning is nothing like what the end product looks like. The more you test it, the better it becomes. And it takes a community of people. You need diverse viewpoints and opinions and backgrounds in order to make the thing really work. So we have thought about an expansion for Extronaut, and that would bring rockets up to date and maybe go with some more international. Extronaut has all US-based launches only in it right now. I mentioned we sold about 10,000 copies. That's kind of a nice break point for an expansion set. You have a big enough customer base that an expansion makes business sense. And I've learned a lot about how you run a small company and challenges that go along with that.
Right. That's interesting. A couple more questions kind of building off of that. Launchpad Astronomy asks, is this KSP as a board game or Kerbal Space Program? And then again, kind of adding to that, Johnny Spacer says, have you thought about making it an online game?
So first, is it Kerbal Space Program? It's related. I mean, it's got the same kinds of themes. You're putting together rockets. You're trying to land on the planets. It's competitive in nature, so you are playing against other players. In Downlink, we made this really interesting cooperative aspect of it. So a player can put an instrument on somebody else's spacecraft and actually use the spacecraft or use the instrument on their turn. So I don't believe Kerbal has that, at least when I used to play it. When I actually had to take Kerbal off my computer because I wasn't getting any work done.
we hear that a lot.
Yes.
Yeah.
My life, just because it was so much fun. What was the second question?
Have you thought about making it an online game?
We have. It's actually a lot more expensive. One of the great things about board games is a couple of people can do it, and then it only takes a few $100 to $1,000 to print the prototypes and test it. A computer version of that's a lot more expensive. We would definitely be interested if there was somebody that had those capabilities and was interested in partnering with us. But we're not operating at anywhere near the kind of budget levels that would allow us to go into video games right now.
That's awesome. That's awesome. Personal question, if you don't mind. Personal question meaning I have a question, which is a very rare occasion for me. I'm typically just speaking on behalf of the chat room. So you were talking earlier a little bit about how you like the combination of science and art. And so it would feel to me that this creation of this game would allow you, again, to make that connection. If you can tell me, what your joy in creating this game, where that came from. Does that kind of make sense?
Sure, and definitely working with the artists for the game is a lot of the fun, because you have these ideas. I'm not artistically inclined myself. I draw and I do things like that, but it doesn't look anything like what these amazing posters look like behind me. We have artists that we work with that are just amazing. And Downlink has a lot of art. Particularly our second game, Constellations, that was one where we had a lot of fun with the artwork, because we got to kind of reimagine all the different constellation characters and animals and scientific instruments that make up the night sky. So I absolutely love it. There's nothing like the moment when you've been working on this thing. It usually takes about 2 years from concept to finally getting the box from the factory with the final game in it. When you get that and you open it up and you're like, wow, it actually happened. We actually made the product, and here it is, and it just looks amazing. It's just a really great sense of accomplishment. And again, a team effort. That's one of the things I really enjoy, is when a group of people come together with a common vision and you make something really amazing happen. That's a great answer.
Yeah.
Actually, a question that came out of the chat room, kind of based off of you talking about this, says, sounds like our guest should be in the running for the Dear Moon project, and would you go?
So remind me what Dear Moon is.
Yeah, so Dear Moon is the project in conjunction with SpaceX. I'm not sure if I'm explaining this correctly, but that is going to go around the moon. And MZ, gosh, I forget his name.
Saku Maezawa.
Thank you.
Maezawa.
Yep, has bought the ride and all the sort of tickets on it to go around the moon on a SpaceX BFR spaceship or whatever it is that they're calling it these days. To give artists a perspective so that the artists then can come back down to Earth and sort of share that newfound perspective with the world.
Through art. Yeah.
If I had the opportunity to fly around the moon, I would absolutely take it. I might have a veto from my significant other, but other than that, I'm in.
Well, I mean, it's Apollo 8 style. You're definitely coming back, so I mean, that's good. Do you think?
I get it. Yeah, you don't have to sell me. I'm there.
I'm the same way with my significant as well. Like, not going without me, that's just not going to be a thing. So, totally understand that. That's awesome.
So,
something that.
Oh, go ahead, Mike.
Something that I have a question about is some of the competitive elements to it. Is there anything that would be almost Risk-like, where I'm imagining like a board with territories where you put a lander in this territory and whoever lands the most landers wins or something like that?
Yeah, the way we do that is whenever you build a rocket or a spacecraft, a connector opens up. So if you want the Falcon Heavy, which is the biggest rocket in the game, and it'll score you at least 7 points if you launch it. The game's playing to 30 points. But as soon as you play that, the connector for the spacecraft opens up, and on another player's turn, if they have a matching spacecraft, they can actually put it on your rocket. And their resource cubes are how they claim that. But then you can start to move your resources across those connectors. So if for some reason the player who had the Falcon decided they didn't want to launch that spacecraft because they were going to allow the other player to score points, the player with the spacecraft could then start sliding their resources across and actually take control of the rocket and force it to launch and score the points. So there is an element. Yeah, so this one shows you the different resource cubes and how the connectors line up on the different elements.
Yeah.
So you definitely are doing area control, but the area you're controlling is the hardware that's part of the mission. And that's how you score points in the game, is by getting that rocket launched or getting that spacecraft to its target or downlinking the scientific data from that scientific instrument.
Wow, that is awesome.
I'm thinking tomorrow game night.
Yeah,
right? Yeah, that's exactly what I was thinking. Where can we get a copy of this so that we can have it tomorrow game night?
So right now the game's on Kickstarter. We haven't printed it yet. We always go to Kickstarter to get the funding to pay the factory to print the game. So we are running right now through the end of the week. December 15th is the last day of the Kickstarter campaign. We definitely could use your support. In addition to the game, we put on there as an additional backer reward a set of commemorative coins for the OSIRIS-ReX mission. We worked with a company called the Shire Post Mint. They've done a lot of fantasy kinds of coins like Game of Thrones and Lord of the Rings and Mistborn. And they handcraft these coins. It's an amazing process. So it's a nice keepsake for the OSIRIS-ReX mission as well. And you can choose just to back at a level that gets you the coins or back at a level that gets you the game or both. And there'll be chances for add-ons after the campaign is over. So right now on Kickstarter, Downlink, the game of planetary discovery from Dante Lauretta and Extronaut Enterprises.
Very cool. That's
Very
really
awesome.
great.
Cool. So what's next for OSIRIS-ReX? Because you said that this is gonna be a couple years. So what do we have to look forward to with the mission?
So right now we are doing the polar flyover. So just a couple of hours ago, we completed the third flyover of the spacecraft over the North Pole. We've got a pretty good handle on the mass of the asteroid. Next week, we'll be doing flyovers of the equator and the South Pole. And these are hyperbolic trajectories. So we're just kind of flying over, like buzzing the asteroid, getting a sense of the mass, and also getting some of our really high resolution imagery. On December 31st, we're going to put the spacecraft into orbit. And that's where the flight dynamics team kind of makes a transition. Right now, we're navigating using radio tracking as well as star field data. So we take pictures of the stars and we can figure out where the spacecraft was pointed. That technique doesn't work when you're really up close to the asteroid because there's no stars that are visible. The whole asteroid surface is filling the field of view. So we transition over to landmark tracking. And so one of the things we're doing is we're building up a catalog of landmarks that are very precisely registered to the coordinate system of the asteroid. And the navigation team is going to transition from using star fields over to recognizing these patterns of landmarks and using that for the spacecraft what we call the ephemeris update to where it was the spacecraft and predicting where the spacecraft's going over the next 24 to 78 hours. After they're done, and they've made that transition and they're confident in their ability to navigate the spacecraft, we begin the scientific mapping campaign of the asteroid in earnest with a phase we call detailed survey. We can actually leave orbit again. One of the great things about the microgravity environment is we're like a hummingbird. We can orbit, we can leave, we can go back, you can change the inclination, you can change the center-major axis for very little delta V expenditures on your propulsion system. So we're actually going to back off and do a whole series of north-south passes and map with our spectrometers and with our imagers and with our LiDAR, and we're going to build the ultimate global data set of the asteroid. That leads us to a down select. One of the best decisions I get to make is the primary site and the backup site on the surface where we want to get the sample from. And then we start low altitude reconnaissance passes to get that sub-centimeter data, ultimately getting final decision on where do we want to go grab that material from.
Awesome.
Wow.
And Dr.
Question I
Lauretta,
have real quick about the maneuvers is, are you guys going to be attempting any sort of gravity tractor maneuvers?
Well, we're not doing anything that we expect to change the orbit of the asteroid, if that's what you're referring to in terms of the gravity tractor, to try to deflect Bennu or change its orbit in any way. So we're not equipped for that kind of experiment. We are measuring this Yarkovsky effect, which I mentioned is the effect of sunlight that changes the orbit of the asteroid. The only reason we can really do that is because we first pinged it with radar in 1999. We hit it again in 2005 and then in 2011. And now here we are, 2018, 2019, and 2020. So we have a 20-year baseline of orbital data on the asteroid. And that's kind of what you need in order to see a change in the orbit of the magnitude that we're expecting.
Excellent. And Dr. Lauretta, just want to know if you could remind us of the Kickstarter for the game. And in addition, if people would like to get more information about you, where can they go for that?
So Downlink, the game of planetary discovery, is on Kickstarter right now through December 15th. We need your support to get this great game of solar system exploration out and produced. If you want to learn more about the OSIRIS-REx mission, our website is asteroidmission.org. We are also on Facebook as NASA's OSIRIS-REx mission and Twitter as OSIRIS-REx. And I'm also active on Twitter as DS Lauretta.
Excellent. All right. Well, Dr. Dante Lauretta, thank you so much for coming on the show today. A man of a multitude of talents.
Yes.
Most certainly fantastic talking with you today.
Thank you. It was great to be here. I really love what you guys are doing.
All right. And before we head to our break, of course, we got to thank our citizens of tomorrow, our escape velocity citizens who get their names in the show multiple times, $10 or more per episode. So we got to give back to you a little bit. We also have our orbital citizens as well. These folks give us anywhere from $5 to $9.99 per episode. And again, we thank you so much for helping support the show. The shows of tomorrow. Because we have Tomorrow Space. We also have Tomorrow Science. We have some other things maybe coming around. We'll see in the future with things like that. But it's always just incredible that you folks are so willing to support us, and we're infinitely appreciative of your contributions to help make this show as awesome as we can possibly make it. So we're going to take a quick break, and then after this break, your comments from last week's show. So stay tuned. There's more tomorrow right after this.
This girl's a fascination, and nothing in her way will keep her from her destination. 'Cause she's fire walking, when it's hot she keeps on moving, through the heat keeps on improving. Yeah, she's fire walking to be free.
All right, and we're back. Just to let you know, in case you forgot.
In case you forgot. What am I looking at exactly?
Okay, cool. So we're just going to go straight into the comments. And the first comment up is a comment that I chose coming off of YouTube.
I'm so glad you're talking to this because I looked at this comment and I said, I have absolutely no idea
Yes.
what we're doing. What's the context here?
This comment, to give you some context, is that I noted that InSight had set a record for the amount of power generated at the surface of Mars, which I said was 4,200 watts. Turns out I was wrong, and of course, if you're wrong on the show,
we get corrected all
our
the time.
Our commenters are very good at correcting us, which I have zero problems
by the
about
way.
being corrected.
Amazing.
Yeah, so
It's
zero
the
problems.
scientific process, is it not?
Yep.
Exactly. So Nathan Colgan off of YouTube said that it's not 4,200 watts, it's 4,200 watt hours over the course of a day. So it's actually more like 171 watts total. So this made me go down sort of the electrical engineering hole, kind of looking at the difference.
It's a great hole to be in.
Yeah, it is. It's shocking. I mean, it's just electrifying. I mean, just
I'm
a
so
bunch
proud of you.
high voltage things. So
That was so
That
good.
one too.
So as we just
Wait, I missed that. What?
I said, oh my, that was
Yeah.
bad.
Thank you.
Well,
Okay,
whenever
good, 'cause I totally-
whenever electricity puns come, it just amps me up. Like I can't believe. So let's
What
go.
are you guys doing?
Let's just flow back into this.
I just got that one.
So
What?
What?
yeah. So I'm gonna flow here into the difference between a
He's on
watt
fire.
and a
Holy
watt
cannoli.
hour. So a watt is a unit of power, and power is the rate at which energy is produced or consumed. A watt hour, however, is a unit of energy. It's a way to measure the amount of work performed or generated. So they're actually two completely different things.
Okay.
So, which is really, really cool to think about.
So kind of like my watch doesn't list the number of steps I do. It does the number of calories that I burn.
Yes, exactly. Yeah, that's exactly how it would work.
You had watt hours.
All by
Fantastically
myself.
done. So good there. Excellent. All right. So our next comment, Sarah,
Okay.
you speak to it.
All right.
Yeah, please, because this is a wall of text. I can see
Yes.
the slate
Oh,
coming
boy.
up.
And again, I seem to be drawn to
goes
the massive
outside
like
the
dissertations.
I love you.
So this one was from the community and from Frida. And again, apologized for the rant in advance, but I thought this was, we talk about this a lot, and this person had some ideas. How can tomorrow help inspire space? Amateur radio with CubeSats, rocket launches, increase the size of tomorrow's circle by bringing people from not the local Los Angeles area, and push awareness of topical space conferences, et cetera, et cetera. There's a big long list at community.tomorrow.tv, and the person ended up with the things tomorrow does, can, and already do make a meaningful and inspiring difference no other space show or... Thank you. I'm going to not read all of that. Please go and read this. But we are always talking about how we can do more things, and it all requires money, or I shouldn't say that, it doesn't all require money, but we're always thinking of things that we can do and to just make it more interactive. And so if you've got more ideas, please, awesome, let us know.
Yep.
Yeah, it was a really great post on community and community.tmr.tv. If you're not familiar yet, please make yourself familiar. Come by, say hi. We're all there hanging out.
Right.
It's kind of like our forums to a certain extent. So it's really great because then these posts can stay there and live there and then be living, breathing posts.
Yeah.
So you can always go, oh yeah, well I can do this and you can do this and I already do this. So I don't know if you guys do this sort of thing too. And it's it literally is a community. And like I said, we all kind of hang out there. Some of us lurk more than some, but I do still read all the really amazing stuff that you guys post. It's really fascinating. So that was a really great post. And Frida, towards the end there, Frida apologizes for making shorter posts in the future. Don't worry about that. That's what community is all about.
Yeah.
Sarah doesn't always have to pick them, but she likes them anyway.
I do,
Frida
because
helped us with the. I'm sorry, no, I don't have a mic.
Yeah,
but
you don't
Frida
have a
helped
mic.
us with the overview of what the entire organization is.
Yeah, actually,
And
one of
gave us
Frida's
time and
posts.
passion.
It was one of the longest posts that Frida posted, and again, like I said, don't worry about how long that is. Again, community that helped us with the overall vision, really nailing that down for us for all of tomorrow, and you're going to see some really amazing things come out of that. I'm very excited for the future there.
Yeah, it's gonna be really, really great. So, Mike, your comment.
Again,
Yeah,
it's going to need a little
just
context.
Oh yeah.
Just to give you a little context. talking about this week when the SpaceX launch of the CRS-16 and with the failure of the hydraulic fluid on one of the grid fins, John Erickson from YouTube had this to say. Question in next week's show, I think it'll pop up in the news. Yes, it did. Why are SpaceX using hydraulics instead of electric motors to steer the grid fins? Must be weight to save here? Question. And as far as I know, I think that that's accurate. That what they're doing is the hydraulic fluid that they're using is actually being fed from, to my understanding, and please correct me if I'm wrong on this, is being fed from the fuel that is actually being used to burn the rocket. So the RP-1 is used actually as the hydraulic fluid for that. And I'm guessing that there's just one pump for each one of the grid fins. I don't know for sure, though, but the other 3 grid fins continue to work, so I'm assuming that that's true. So I'm guessing that the reason that they do that and don't have a separate hydraulic fluid is to save weight. So, yeah.
Yeah, that would be a good guess, because anybody's guess is as good as anyone else's, because that's probably an ITAR thing, and we probably won't ever get to see that kind of level of design.
Even if I ever get the full answer from a SpaceX employee, I probably could never repeat it. So
yeah, so yeah, if that were to ever happen, so with that there,
probably won't.
Yeah. Yeah, it's all good. So we just know that something happened with the hydraulics. So interesting. So that's it.
Yeah.
We're wrapping up.
Oh,
but
wait, really quickly. It's Vax Headroom in the chat rooms. Oh, I missed the thing and all the other things. Somebody could send that. Said that Tim Dodd, the Everyday Astronaut, has a great video on that.
Oh,
so
yes.
I guess that's really cool. Tim Dodd, the Everyday Astronaut, seems to know all of the things most of the time, and does really, really gorgeous videos anyway. Really good friend of the show. If you're not familiar, please go check that out. Anyhow, Jared.
Definitely. Now we will wrap up the show. Boy, I've done that a couple times during this show so far. Jumped a little
Never
too far
gets old.
ahead.
My fault.
So anyway, no, it's good. So we want to thank all of our citizens of tomorrow now, our escape velocity citizens, who we've heard how much they give us per episode earlier, and also our orbital citizens, who you've heard how much they give us earlier as well. And of course, we got to thank our suborbital citizens. These folks give us $2.50 or more per episode. And this is just great that we have this many people. Like, look at how many people are there. Like, that's a lot of names,
army.
right? Like, it's a small. Indeed, it is a small army to potentially take over the world.
But that's our
with.
army.
It is our army. So that's why it's so great. And then, if you thought that was a lot of names, here's our ground support citizens.
There's the horde.
So
There's a wall of text.
All you have to do to become a ground support citizen is just be like $1 per episode. That's all it takes in order to support us and get your name here on the show. And of course, if you want to, you can go to patreon.com/TMRO. It's not just your name in the show. You get some really cool stuff with it as well. Like, we have a Discord channel for our escape velocity citizens, where basically you get to see us talk to each other. And if you think the puns during the show are bad,
you just wait.
You should definitely see the level of parental jokes that occur in our escape velocity channel.
We also have Patreon Hangouts as well. That one should be coming up shortly. So if you're in the Discord channel, pay attention to if and or when that is what is happening right now.
Ben has appeared.
This is
I
not
don't
good.
have a microphone. I'm sorry, and I was going to put this in the show notes, but I'm running on fumes for sleep, so I forgot. If you are a citizen of tomorrow already, if you could go into Patreon and make sure that you have an address, starting in orbit 12.
A physical address.
A physical address, a mailing address. Only if you're.
I don't know what's happening anymore.
Only if you're comfortable doing it, but we're going to start mailing out physical rewards after you reach certain thresholds. So here's an example. There's the Orbit 12 patch that we've had created.
Nice. Yes. And that's going on my flight jacket.
Yeah, exactly.
Sewing it into my skin.
And there are some pretty cool things. We'll go into that in After Dark and whatnot. But if you have a mailing address, we'll be able to send that out. I'm also working on challenge coins and a few other things. So definitely make sure all of your information in Patreon is updated on what is going on. I'm the one with no sleep. There you go. I will now very awkwardly. I think I'll just
leave.
Yep.
I'm just gonna hide behind you.
Yeah, just lay down. No one's gonna notice.
That's the way this goes now. All right.
All right.
Cool.
Very, very good. Yeah.